Hello, I welcome you all. The problem reads the choice of a seating material for moving vehicles depends upon its ability to resist shock and vibration. From the data shown in the graphs, determine the impulses created by falling weight onto a sample of urethane foam and CONFOR foam. This problem is coming from the Engineering Mechanics and Dynamics 14th edition by R.C. Hibbeler. So we are going to use the principle of linear impulse and linear momentum. Okay, all right. So we know that the area under this each of these form is equal to the impulse, right? And this impulse is just equal to the summation of the force. This is the summation. You can think of this as the summation of the force times the time. Alright, like here we can add it together, or you can say this is the summation of the integral of the force dt. Okay, so we can use either these equations to find the impulse, and this is equal to the mass, okay, times the change in velocity, right? Okay, all right, so let's work on this. So we are going to divide this into two parts. So for this one, we'll divide it into this area. We'll start with the CONFOR. Let's start with the urethane, right? So we'll have this one here. We'll have this one. Okay. Then we'll have this one here. And then we'll have this one here, right? So we have this area here. Okay. Then we have this area here. Alright, and then we have this area here, right, and then we have this area here. Alright, so let's work out. We have four areas. We have 4 areas, so we have 1, 2, 3, 4. So let's work it out. So we are saying we are dealing with the urethane. It's urethane, right? Form. Okay. So we said it's the area under this curve, so which we can calculate. So let's calculate it. So we'll say impulse. So we'll say summation of the force times the time, right? And this is just going to be equal to, mind you, the time is in milliseconds, so we'll need to multiply by 10 to the power 3. So this just becomes, we'll say area 1 plus area 2 plus area 3 plus area 4. Then this just becomes equal to, let's work out these areas. This is a half by 0.3, which is the force, by 4 times 10 to the negative 3 plus this one is the second area, is the trapezoid. So we have half times our A here we have 0.03 plus our B we have 1.2, and then we have this distance in between the time, which is 7 minus 4, then times 10 to the third, then plus area 3 is a trapezoid as well, so it's half, and then we have 1.2 plus 0.4, and then we have a 10 minus 7, 10 to the third, then plus we have a half by 0.4 by 14 minus 10, then by 10 to the third. Okay, therefore our impulse for this is just equal to let's work it out. Okay, so impulse is equal to 0.5 by 0.3 by 4. I'll multiply that by everything by 10 to the negative, and plus 0.5 by 1.5, okay, by 7 minus 4 is a 3, then plus 0.5 by 1.6 by 3, okay, then plus 0.5 by 0.4 by 14 minus 10, which is just a 4, and everything times 10 to the negative 3. Alright, so then our solution becomes 6.05 times 10 to the third negative 3 newtons second, or Newton millisecond. So this is the time for urethane. Okay, let me check it again. 0.5 by 0.3 by 4 plus 0.5 by 1.5 by 3 plus 0.5 by 1.6 by 3 plus 0.5 by 0.4 by 4. Okay, how come I'm getting a different answer? 0.5 by 0.3 by 4 plus 0.5 by 1.5 by 3 plus 0.5 by 1.6 by 3 plus 0.5 by 0.4 by 4. Alright, it's fine. So we found this one. Let's move on to the second one. So let me wrap this. So we are on the CONFOR form. So say CONFOR form. Okay, it has been capitalized. Let me do the same also. Sure, those are abbreviations, right? So let's check out the impulse for this one. What do we have? So let's divide this. So we have this area here, and then we have this one there, right? So there we go, this one, this one, okay, this one, like so. Right. So let's work out this. So let's call this one here 1, we call this one 2, then 3, area 3. We have 3 areas, 2 triangles and 2 trapezoids. So say summation of forces times the time is just equal to area 1 plus area 2 plus area 3. So this is just going to be equal to, this is equal to, that's half by 2 by 0.5, okay, 10 to the negative, plus this other one, trapezoid, half by 0.5 plus 0.8 by 7 minus 2 by 10 to the third, plus in the last triangle we have half by 0.8 by 14 minus 7 by 10 to the third. Therefore, this CONFOR, okay, CONFOR is just going to be equal to, so we have 0.5 by 2 by 0.5 plus 0.5 by plus 1.3 and by 5 plus 0.5 by 0.8 by 7. Okay, so this one gives us a 6.55 times 10 to the power negative 3 Newton meters. Alright, so let me check it. 0.5 again by 2 by 0.5 plus 0.5 by 1.3 by 5 plus 0.5 by 0.8 by 7. Okay, alright, I guess we are done. So the question here was to determine the impulses created by the following weight onto the sample of urethane foam and CONFOR foam. Alright, so which of the two materials do you think has the highest impulse, okay, or the one that can resist a large amount of shock and vibration? Of course, it is this one, right? It is this one, right? So this one can resist a high magnitude of shock and vibration, right? Okay, so I think this is about it. Let's just outline our final solutions like so, and we outline that one as well like so. I think this is about it, and I hope this particular video was helpful, and if it was, give me a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screencast.